I'm going to take an example to demonstrate cluster analysis. So we'll use SAS for this. Cluster analysis is an unsupervised learning technique. So it's different from the supervised learning technique that we have learned in the form of linear regression, logistic regression, and so on. So unsupervised learning algorithms are used for unleveled data. So data for which there is no target variable or dependent variable. So if dependent variable is not available for a data, supervised learning algorithms such as logistic regression, linear regression, decision tree, random forest, and so on. So these algorithms are of no use when we do not have a target. So target variable is the one which levels your data with a continuous value or a categorical value. But many times we do not have the luxury of having a level data with us. So how do we do analysis, data analysis using unleveled data? So we'll use cluster analysis for that. I'm going to take an example to show you how we can use different clustering techniques and what's the real world uses of clustering techniques are. So what happens in cluster analysis is that the algorithm combines similar observations into different groups without the help of the target variable or the level data. So it tries to combine observations on the basis of distance. So if the two observations are very close to each other, now remember we could have different features. So we could have a number of independent variables or number of features or number of different aspects of the data, but there is no level as such. So measuring distance between two observations is simply the Euclidean distance, which measures the difference or the distance between two different observations. So if the two observations are very close by, we call we can or the algorithm can group them into a same cluster. So the idea is that the distance between observations within a cluster should be very low, and the distance between observations between clusters should be high. So that's the idea. So having this in mind, let's take a data set and understand how we can use clustering algorithm to analyze data. So clustering is used in a number of real world uses. One way is to come up with different groups. So having different groups helps us in understanding different segments in your data. So in real world, let's for instance we have data for customers and we don't have labels like what type of customers we have. So we can use clustering to come up with different groups or different clusters, and then we can have different marketing or sales strategy for different clusters. So one of the most popular use of clustering algorithm is used by Google. So what Google does is it combines the different news items related to a particular event. For instance, Brexit is one event or one news event. So it collects all the news articles on Brexit based on different features. So now this is not a level data because news articles as such are not of any type, right? So nobody says that this is on Brexit, right? So based on different features or different data related to the articles, Google clustering algorithm, it combines articles into different clusters, different groups, and it shows on different news groups, right? If you go to Google News, you will find news items have been clustered into different news groups, right? So one event have 5 to 10 news articles from, let's say, CNN or BBC or Economic Times or Times of India and so on. Okay, so we'll take an example here. So we'll take the iris data. It's a famous data. So those who haven't seen data, iris data, let me show the data set to you. So it has got 150 flowers, and we have different aspects, different features of the flowers: sepal length, sepal width, petal length, and petal width. And these flowers have been categorized into different species. There are 3 species: Setosa, Virginica, and Versicolor. Now this data has got the levels. So our target variable in this case is species, which has got 3 levels. But in real world, we won't have this level data. So we'll drop this variable to make it more appropriate for clustering algorithms, right? So in case we have already a level, there is no point using this data, so we'll drop this one. So we'll drop this here. So we'll use iris1 instead. Okay, so there we have got 150 observations in all, and after we have dropped species, we only have the 4 observations, right? So let's print iris1, which doesn't have species. Now you can see we only have the independent variables, or the different features, the 4 features of the flowers. Now using these 4 features, we'll categorize them into different levels, and finally we'll compare whether the actual categorization is correct as compared to the one done by the clustering algorithm, right? So that luxury we have because we already know the categorization here, because it's a level data, we have made it unlevel one, right? And that's a challenge in fact while building real world problems, because you do not have a label as such prior to using your clustering algorithm. Alright, so in SAS we can use several procedures. One of the important one is proc cluster. Syntax is very simple. You provide the input data and then you provide the method that is going to be used. There are several methods to be used. Now the way clustering algorithm works is it combines the data points. Okay, so first what it does is that it combines 2 data points, the closest ones, right? And when 2 data points have been combined, so each 2 data points will be combined. Now we have cluster of 2 data points, right? Now when it combines, it calculates the distance between 2 data points. Now that's not possible between 2 clusters, right? So 2 data points have been combined into a cluster. We need to combine, in the next step we need to combine 2 clusters, and calculating distance between 2 clusters is difficult. So there are different methods of calculating distance. You could take the maximum distance, that means the maximum distance between a data point in cluster 1 and data point in cluster 2, or you could take the mean, or we are taking the centroid, so that's why it's called centroid. So there are other methods as well, so you can try out all the possible methods that you can use and see if the clustering pattern differs. That helps actually to understand the data better, and the one that gives the best result is to be finally selected. We're going to print like that there is going to be 150, so look clumsy, so we'll print only 15 observation how the clustering happens, and we'll understand in that way. We'll have the option called CCC, which stands for cubic clustering criterion, which is going to help us finding out how many clusters are going to be there finally. So it helps us understanding how many clusters are going to be there. Pretty much like principal component analysis, where we're trying to find out how many principal components. So what's the optimal principal component? Here we have how many. What's the optimal clusters we're going to have. Outtree is being used to take the output of this and save it in a data called tree. You can give any other name. So let's run this. So the variables that we are using are the independent variables: petal length, petal width, and sepal length and sepal width. Now slight difference in the syntax. We are not explicitly mentioning the names of these variables. We're simply giving petal, and it's going to take anything that starts with petal, right? There are 2 variables with petal and 2 variables sepal. Okay, so let's run this and we'll get the result, and then we'll interpret the result, and then finally we will visualize the clustering pattern, and we'll understand whether it works fine or not. In the output, the first section will have the eigenvalues. Now eigenvalues actually in a rough sense, it explains the variation in the data, and the first eigenvalue would obviously explain the maximum variance. Okay, it's 92%. And then when you go to the next one, combine the first one and second one, you are able to explain 97%. So the cumulative percentage of the cumulative percent of variance being explained by these 4 variables, 4 independent variables, is 97%. And when you the third one, we are reaching at 99%, 99.5 in fact. So it gives us an indication that 3 clusters are quite enough to explain the different grouping patterns. Okay, so we're probably going to have 3 clusters. That's just an indication. We'll be sure by looking at the CCC plot. Okay, we also have the cluster history. Now when you look at the cluster history, you're going to we only have 15 observation. Of course, if you don't explicitly mention to print 15, it's going to print all of them. Okay, so how the clustering happens is that, you see if observation 57 have been combined with observation 112, and we have got one cluster, right? And then two clusters, small cluster, can be combined to form a bigger cluster, like cluster 23 and cluster 24 have been combined to form another cluster. Now in each, when we combine two observations, we're going to have a frequency, like how many observations finally we're going to have in that cluster. So here two observations have been combined, so we just have two observations in that cluster, it forms one cluster. But here two clusters have been combined, so we obviously will have more than 4, right? We have 34 observations in this case, and so on. So you can see that for all 150 observations, and there will be several clusters. So the recommendation that will be done by the algorithm is that you're going to have several clusters, but question is, what is the optimal one, right? So that's what matters to us, and we'll get to know the optimal number of clusters by looking at the CCC plot, or what we know as cubic clustering criterion. By looking at the cubic clustering criterion, we'll get to know how many clusters we will finally have in our as part of the output. So how we get to know is by looking at the peak. Now you can see the peak is at 3, right? If you draw a perpendicular from this peak, you will reach somewhere here 3, right? So here is 1, 2, 3, 4 and 5, right? So that's what is in x-axis. So we are sure, we are clear here that we're going to have 3 clusters, which is going to explain the variation in the data. Now question is, so what is the final output? Okay, what are we trying to look here? So we want to categorize each observation out of this 150 observations into a given or a single cluster. So there are 3 clusters to be there, because we have found out that 3 clusters are going to be the optimal number of clusters. So we'll use proc3 to finally have this 3 cluster out of how many number of cluster it started out with, right? It started with many other clusters, many number of clusters, but from the diagnosis and by doing the diagnostic analysis, we came to know that we only want 3, right? So we'll use a keyword NCL equal to 3, which is going to give us the 3 optimal clusters, and the output is going to be saved in a data set called out. Okay. All right. So let's see what's there in the data set out. Okay. So initially the clustering algorithm, I guess it gave us 5 cluster. Okay. So this was the first, that by default it gave us 5 clusters, that this data is suitable for 5 cluster. But when we did the diagnostic analysis by ourselves, we found that 3 is better than 5, because 3 is what is being explained, able to explain 99.5% of the variation. So there's no point in having 5 clusters. You can see cluster 3, cluster 5, right? So that's maximum of 5 clusters being recommended. Whereas by limiting it to 3, we are now able to categorize each flower into a given clusters. Like first flower have been categorized to cluster 1, second with cluster 2, cluster 1 again. Okay, sixth observation is cluster 3, right? Now what these clusters are, we do not quite know, because this is unleveled data, right? So one of the way we can analyze this data is that, given the fact that we already have a level data, we already have a species given to us, we can compare the cluster over here with the species and see how accurate is the model. But that luxury is not available in real world data, where you do not have any predefined classification. So only what we have received from the clustering algorithm is going to be used finally, right? And only when you get a feedback from the production, you'll get to know whether it actually works correctly or not. That's the way we validate that, right? um, so once that is there, we will draw what is known as a dendrogram. Now that helps us find visually understand how the clustering algorithm works, and it's very interesting. Let me show you. It's easy. Syntax is like we are using proc tree to plot how clustering algorithm has worked. So clustering algorithm is very simple. It simply combines the nearby observations by measuring the Euclidean distance, and we will get to see the plot and understand how. So what has happened is that we have this observation 150 observation in the y-axis, and you will see the smaller bars by combine. So that's the way it has combined. Finally it has got a big cluster, right? The final, this one, the one where I have the arrow mark. Now you will see that most of the difference you can see is between this group, the one that I can show here, then the next one here, the one where we have the arrow mark, and the one is here, right? So we can see visually that there are three different groups here, right? And that's why we have three clusters. Okay, so that's one way of deciding whether choosing three cluster is actually okay or not. So this is one way of diagnosing your result. Also we can use a scatter plot to see the distribution of clusters once we have uh, categorized each observations. Now that we have clusters, we have categorized each observation into a given clusters, and we have got three clusters. Let's do a scatter plot. So we'll use proc candix for this, okay, and we'll use a class as a cluster, because cluster is the one that's where we have the three cluster, right? So this is the variable we are going to use to do the visualization, and we'll use proc sgplot to to do the plot, okay, to do this scatter plot. So when we run this, we will, okay, so this is the one. Now you can see there is a difference in the three clusters, right? So this is one cluster, this is one cluster, and the red one is one cluster, right? There's a clear segregation of the three clusters. The slight overlap between the red one and the blue ones, but other than that, the green ones are far away from the other observations. So that clearly it says that the clustering algorithms works fine in segregating the observations. So that's good news. That's one good way of validating your result by creating visual plots. So where in the real world we find uses of cluster analysis. Many times we do not have target variable, and that's when we find analysis of data very difficult. If you already have a target variable, then it's good to go with the supervised learning algorithms, which is going to do a great job. But if we do not have that luxury, we go for cluster analysis. It's used heavily in market segment, in knowing market segments. Many times we have the data for consumer and do not know how many segments or cluster of customers do we have in our portfolio, right? To know that, we get different features of customers, their income, their age group, and so on, and then we use clustering algorithm to come up with different groups, okay, and then we use different marketing or sales strategy for different groups, okay. News aggregation, I have already said about that. Consumer analysis, whether in e-commerce industry, whether in FMCG industry, and so on, is heavily used.